Hello, everybody. Hope you had a great day. When are you going to be watching this video? I guess I should really just stop talking about the days because it obviously messed me up so much last time. But today you're going to need a couple things. You're going to need that foldable that we passed out at the end of class and something to write with. Today's lesson is highlighting all about parallel and perpendicular lines. So take a second and just kind of picture some in your head, or maybe you already looked at your foldable. So that is what our main focus is. So we focused on lines in general, and now we're looking specifically at parallel and perpendicular. So let's take some quick definitions here, and then we'll move on to our foldable. So a parallel line, okay, is, so you can have, we're going to just look at two lines here today. So two or more lines in the same plane that never intersect. And in this case, so that might be the first part, but the second part's going to be what's new to us, and it's going to be and have the same slope. Going to have the same slope. That's going to be key. Alrighty, and then perpendicular lines are ones that intersect, but they're going to be a little bit more specific. They're going to intersect at a 90-degree angle. So perpendicular lines are two lines in the same plane that intersect to form right angles. And in order to do this, the slope, or both the slopes of the two lines, the slopes, let's just put that in there, of the two lines must have a product of -1. So let's give an example of this. So if I had a slope of, let's do -3. So if I had a slope of -3, I would need to figure out a number that when I multiply it to -3, I'm going to equal -1. So if my slope is -3, my perpendicular slope is going to be a +1/3. And how you can check that is -3 times 1/3. When we multiply together, we get -3/3, which is equal to a -1. So lines can cross, lines can intersect, but in order for them to be perpendicular, both slopes must have a product when multiplied together equal a -1. So that's the tricky part there. So let's scroll down to the foldable and start off with the parallel lines. Again, we need to have the same slope. So I've got two examples here that I'm going to go through. And the first step, what we're going to do is write equations of these lines. So if I'm looking at A and B, remember I need to find the slope and the y-intercept. So my slope, by counting, I'm going to go up 1, 2, 3, 4. So I went up 4, to the right 1, 2, 3, to the right 3. So my equation of A is going to be y equals 4/3 x. Now I look at my line and see where I intersect, and I intersect at 2. So my equation for AB is going to be y equals 4/3x plus 2. Let's see if I can zoom in real quick. Let's see how close. Ooh! Well, that's a lot nicer. Okay, so now that we're closer together, let's look at CD. So again, looking at my points here, I'm going up 1, 2, 3, 4. So when I'm writing my equation, my numerator will be 4, and I'm going to the right 1, 2, 3. So 4 over 3x. So they have the same slope, so they're going to be parallel. And my y-intercept here is going to be -2 because I'm underneath the x-axis 2 units. So again, we're looking at reviewing writing equations from a graph, but to make sure that we're parallel, we have the same slope. And that's all we're looking for today. Okay, so if you want to pause and try letter EFGH, you can. And if you paused, welcome back. Okay, so again, we're going to be writing equations in slope-intercept form. We need to identify the slope and then the y-intercept. So for EF, I'm going down 1, so that's going to be a -1. And then to the right, 1, 2, 3, 4. So -1 over 4. Don't forget your x. You can forget it in any other context but writing equations. Alrighty. And then we need to find our y-intercept, which we look and see where we cross that y-axis, which is going to be a +1. So my equation of EF is y equals -1/4 x plus 1. Now, if you want to cheat the system a little bit, you can look at this line here and say, okay, they're parallel, but I want to use it, I'm going to test to see like if it is the same slope. So I'm going to go see that I'm going indeed down 1 and to the right 4. So I'm going to have -1 over 4. And then don't forget your x. The y-intercept here is -2. So a little bit of review, a little bit of new stuff. So let's just write down some final thoughts here. So little fun facts, if they have the same slope, the lines are parallel. Okay? And you can also say, go the other way. So if the lines are parallel, they have this, if they have the same slope, they're parallel, and if they're parallel, they have the same slope. Wow, I just kind of lost my train of thought there. Okay, get it together, Miss Hardaway. Oh, I'm hungry. Okay. Brain fart. Okay, so that can go either way. Alrighty, once you're finished, we can close that. Open that up to perpendicular. Okay. So take a look at these lines. Look at those right angles. Wow, they look nice. Okay, so the first thing we're going to do is find the slope of each line. So I'm going to start with AB. I'm going up 1, 2, 3. 1, 2, 3, 4. Oh. If I could stop and redo it, I would. Okay, 1, 2, 3, 4, 5, 6. So I went up 6 to the right 1, 2. So if I want to put this off to the side, 6 over 2, that can be simplified into 3. So y is going to be equal to 3x, but I need to check and see what my y-intercept is. It's right there. So 1, 2, 3, 4, 5. So it's going to be 3x plus 5 for AB. And then I'm looking at CD. Alrighty, so y equals, I'm going down 1, so I have a -1, and the lights went off. 1, 2, 3. Oh, wow, it would help if my hand wasn't covering it. Okay, 1, 2, 3. So it's going to be -1 over 3x, and then my y-intercept is a +1. So let's talk about these two slopes here, okay? So if I took 3 and I multiplied it to a negative 1/3, what would I get? Just like our first example, negative 3 over 3, which is equal to a negative 1. So that's how we know our lines are going to be perpendicular. Alrighty, now let's look at the next example, and I'll make sure my hand doesn't cover it too much this time. Looking at EF, I'm going up 1, so that's my numerator, and then to the right 1, 2, 3, 4. So I have a positive 1/4 x minus 1. Now before we write the next line, let's oh my God, what word am I looking for? Let's predict, wow, okay, that took way too long to think of. Let's predict what our other slope is going to be. So if I have a positive 1/4, what does my slope of my other line need to be in order to be perpendicular? Okay, so now let's see if that's what we thought it was going to be. So I'm going to go down 1, 2, 3, 4, 5, 6, 7, 8 over 1, 2. So I have a negative 8 over 2, which gets simplified into a negative 4. So let's check. Negative 4 times 1 over 4 equals negative 4 over 4, which is equal to a negative 1. So perfect. These lines have perpendicular slopes. And our y-intercept on this line is 1, 2, 3, 4. So negative 4x plus 4. Okay? And what these slopes are, again, those are called the negative reciprocals. Okay? They have a product of negative 1. So if the slopes have a product of negative 1, the lines are perpendicular. And then alternatively, if the lines are perpendicular, the slopes have a product of negative 1. Alrighty. Now, this lesson, just so you guys know, was a nice little introduction to parallel and perpendicular lines. We're going to look at some other examples when we get to class tomorrow. So with this in mind, I want you to come in with just a rough understanding of parallel and perpendicular lines. If this makes sense, awesome. If you have questions, make sure you add them to the Google form. And then that is going to be it. But I am going to leave you with something funny that I heard from a 6th grade teacher. And she shared it with me, and it totally made my day. Let me see if I can find it. Okay, so the teacher asked, "What is a reciprocal?" And the 6th grader replied, is it a recipe for a popsicle? So I hope you found that as humorous as I did. My delivery probably wasn't as great, but that is pretty cute that somebody in the building thinks that a reciprocal is a recipe for a popsicle. Alrighty, I will see you guys tomorrow. Bye!